Hi, this is my video number 22, right? Number 22. Can you see that? Okay. Alright, so I'll still talk on the line integral. In the last video, the last lecture, I think I gave the line integral in the for smooth curve. Now, what about the integral or line integral with the piecewise smooth curve? Yeah. So we begin with those definition, and then I give you a few examples. Right. Definition. So if a piecewise smooth curve, yeah, if C is a piecewise smooth curve, where C is given as Ci, so I 1 to n. Yeah, if Ci is piecewise smooth curve, right, then the line integral, then the line integral of f along C, of f along C is given as so we integrate C, yeah, f ds. This is we integrate C1 f ds plus C2 f ds and so on. Cn f ds. Okay, in some book we can also write this as a C1 plus C2 plus Cn f ds. Just the meaning. Yeah, you can write that as well. So what do we mean by this? What do we mean by this curve? This curve means that if you have a piecewise smooth, or smooth part by parts, all right. So let's say this is C1, so we have C2, we have C3, and we have C4, and so on. Yeah, so and so on. Cn. So this C, if you can see from C1, from that point to that point is smooth there, but here we got it's not smooth, and again C2 from that point to that point is smooth, but here is not smooth, and then so on and so forth. So we cut each of the part that not smooth, so to make it all those curve smooth. Yeah. So this we call it as a smooth piece by piece or piecewise smooth curve. Let's say example. So we want to evaluate C along CF dot dr. Yeah, here given f ds because this is the real function as well as, so we integrate with the real function. In this case, we have a vector function. Okay, in terms of theory, we still have the same. The definition we still have the same for the piecewise smooth curve, where f is given as yzx, yeah, and C consists of line segment, consists of line segment C1 from 200 to 345 and the C2 from 345 to 340. So that's our C. So if you look at that C1, C2, I think if you could sketch this, it will give a more clear view of what does our curve look like. Yeah, so let's write that. So we have this is in 3 dimension because we have 3 point x, y, z there. So let's sketch those things. So let's say that's our x, y, and we have z. Let's say this is our z. Okay. Now C1 from 200. So let's say 200 is sorry. This is x. Sorry, x, y, z. X, y, and z here. So 200. Let's say those point 200. Let's say here. Let's say 2. Yeah, 2. And then to 345. 345. We have 3 and 4 probably somewhere here. So we have those. And 5. So you need to lift this a little bit longer. Let's say that. Okay, so this point, and from this point to that point. So this is C1. Yeah, this is C1. Okay, for C2 we have 345 to 340. 340 is here, this point here. So that this is our C2. Now our C consists of C1 and C2. Yeah. So now we're going to evaluate f dot dr with C. With our C here is C1, C2. So this, what we can do is we split into 1 by 1. So we have C1 plus C2 f dot dr. So this is what we're going to do. Now first we consider C1. We need to determine what R is. Yeah, because in the evaluation here we need R, then we have to differentiate R. So we need to determine what R is. So this is our graph. This is C1, or this is our curve. That's our C1. So this is just a straight line. It's not easy for it's not difficult for you to find the equation for C1. Yeah. So for C1, we have x 2 plus t, y 4t, and z 5t, where t from 0 to 1. That isn't difficult for you to determine. I hope you have no problem with that. Yeah. And as well as how to determine t, you can choose one of this point. I prefer x. So you can see from this, x is moving from 2 to 3, right? 2 to 3. So you can choose those. Then if x equal to 2, you got 0. If x equal to 3, you got t equal to 1. So that you have t01. Okay. And our f is given as what is it? yzx, y, 4t, 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 y, 4t z, x. Yeah, if you substitute those x, y, z into there, so what we have, your x is 2 plus t, your y, sorry, this is y is 40, yeah, 40, z is 5t, and x is 2 plus t. That. Okay, and for r, your component for r is xt, yt, zt. You can just put there. So xt is 2 plus t, yt is 40, and zt is 5t. So we need r prime. So just differentiate those things. That will give you 1, 4, and 5. Okay, so therefore integrate over C1 f dot dr. This is, we have integrate C1, our f is that, we have 40 dr, this is r prime dr dt, should be dt here, yeah, because this is our dr. So 4, where is it, our f is 40, 5t, 2 plus t, dot dr is given as that 1, 4, 5 dt. And t is from 0 to 1. So you can evaluate this, integrate from 0 to 1, and perform the dot product there. So that we have 40 plus 5, 4, 20t plus 2 plus t plus dot 5. You got 5t plus 10. Yeah, this is 20t, 40, 20t. This is 10 plus 5t dt. So this is not difficult to do. Integrate those things, so you have how many t there? 0 to 1, 40, 20, 24, 29t. Yeah, 29 t plus 10 dt. That give you 29 over 2 t squared over plus 10 t from 0 to 1. That give you 29 over 2 plus 10. That give you 49 over 2. So this is for C1. So you need to evaluate for C2, along C2. For C2 we have our curve C2 from that point 345 to 340. Only z change, right? Z change from 5 to 0. X and y doesn't change. So you can find the equation for this easily. I just wrote down the equation. X equal to 3, y equal to 4, and z equal to 5 minus 5t. And your t, you can find your t is from 0 to 1. Again, you can use z, because z from 5 to 0. When z equal to 5, you got t is 0. When you got z equal to 0, you got t equal to 1. So you have those things. Then we evaluate integrate C2 f dot dr. So before that, let me write down what f is. Our f is yzx. Okay, those yzx, we substitute everything there. So you have 4, your z is 5 minus 5t, your x is 3, so that your f, and your r is x3, y4, and z is 5 minus 5t. We define dr, then dr is, we have 0, 0, minus 5 dt. Okay, so therefore f dot dr integrate C2 f dot dr, this is integrate, our C2 is from 0 to 1, 0 to 1 or 1 to 0. Let's check this. When z equal to 5, you got 0. When z equal to 0, you got t equal to 1. So 0 to 1, yes. 0 to 1. Yeah. And then our f is 4, 5 minus 5t, 3, dot our r, dr is 0, 0, minus 5 dt. So you can easily solve this. You got 0, 0, and then minus 3 minus 5, you got minus 15. So integrate 0 to 1 minus 15 dt. So this gives you minus 15 t. Okay, from 0 to 1, that gives you minus 15. And then I write it here because I just need a very small space. Therefore, to integrate C f dot dr, this is, we evaluate C1 f dot dr plus integrate C2 f dot dr. That give you f1 is 49 over 2 plus C2, we got minus 15, minus 15. Solve this, you got 19 over 2. So this is the solution. Okay. So that for the case of piecewise smooth curve. I give you one more example before I end up this lecture. This is for the case of just a straight line where you can find the equation quite easily. Yeah. So what about if I have let's say example, if I have say f, so let's say this is example 1, 2 already, x squared y, x squared and y, just 2 dimension. Okay, the question is, and our C given as, okay, let me sketch this thing. Okay, this is 1 0 1 1 minus 1 1 minus 1 0. Okay, so the question is find the work done by force F to move an object from 1 0, so 1 0 to minus 1 0. Okay, where for the first case you need to consider that as C1, C2, C3. So where for the case C, we want to consider C1, C2, C3, whereas for the second case, try to evaluate the same location, yeah, from 1 0 to minus 1 0, but using that. Let's call this C4. So C equal to C4, just that, a straight line. Okay, so this case again just a straight line and just 2 dimension. You can try that. You can solve by yourself that one. So I just leave it as an exercise to you. Okay, and then number 2, I think I'm going to help you to solve this. Let's say we have f is given as same as above, x squared y. Yeah, but our curve is given as this. Let's say we have that this is y. Y equal to minus x squared plus 1. This is from 1 0 to minus 1 0 using that. This is your C. Okay, for the second case here, let me recap again this example. First case here, I want you to do to evaluate the force, or to evaluate the line integral, yeah, f dot dr C, where your C here is, we have 2 cases here of C1, C2, C3, that the first case, and the second case is C4. So you should have I guess you should have a different value for that, even though we move from one point to initial point, and the final point, terminal point, is the same for those C, but because the path is different, then we give you a different result. As well as this, yeah, we use same force, again same initial and terminal points, but we use different path. So let's see for this one. I'm expecting you got a different result, I guess. So for this, we want to evaluate C f dot dr, where your f is given there. Yes, your f is given as x squared y. Now you need to change this. Your r is given in terms of y equal to minus x squared plus 1. So remember that for r we need x and we need y, x of t of course, and y of t, yeah, parameter t. So how can we transform this equation into vector form? Yeah, so of course you can by letting, let's say in this case I put x equal to t, then we can have y equal to minus t squared plus 1. Of course you can change, or you can let y equal to t, but you need to write x in terms of t. Then you got square root and everything, because x you have square root here, x you have square here. So that's when you want to evaluate, and the next process is not quite comfortable when involve a square root. Okay, so if you put x equal to t, then your calculation will be much more direct. So in this case, having done that, your r is given as your x is equal to t. Sorry, this is r, not r prime. So just r, and your y is minus t squared plus 1, and then you can find dr from there is 1 minus 2 t dt. Okay, so therefore you can determine what C is. Now for C f dot dr, you need to determine what is the limit of integration here for C. So you can see here C (10) to -10. So since we take x equal to t, let me write here, we have x equal to t, and x change from 1 to -1. When x equal to 1, we have t equal to 1. When x equal to -1, then t equal to -1, because x equal to t. So therefore our limit of integration is from 2, from x equal to 1 to -1. So x equal to 1 minus 2 minus 1. Yeah, it's not from the biggest value of t to the highest value, to smallest value of t to highest value of t. No, it's from where to where. Okay. Now, having done this, just substitute f and dr to there. So we have our f. Where is our f? I don't put f here, so let me write here. So our f, we have x, we have y. So our f is, let me write here. Our f is x squared. Our x is t. So now we have t squared. Our y is minus t squared plus 1. So therefore, CF dot dr, that we integrate from -1 to 1, our f is t squared minus t squared plus 1 dot, our dr is 1 minus 2t dt. So this give you integrate from 1 to -1. So we have t squared plus, here you have 2t cubed, correct, and plus minus 2t dt. Okay, you can easily evaluate this. So what you got? Minus 2, so we have minus t squared over 2 squared, 2 cancel out, so we have minus t squared. That one you have t to the 4 half, so plus 1 over 2t to the 4 plus, that one you have t cubed over 1 over 3. Then evaluate from 1 to -1. Unfortunately, I don't have a solution here. You can just evaluate this whatever. Yeah, it's not difficult. So you can try this. Again, you can evaluate using, if you use C that one. What if you use just from 1 0 to -1 0 using that straight line? What is the solution should be? Okay, and then I want you to try one more exercise. Say let's say that one 2, this is 2, this is number 3. I've done that one, and number 4. If you have this is your C. That's your C. 1 here, 2 here, 3 here. This is your C. Your F still, you can still use same f as x squared, y, and let's say for z, I want to give something here. No, we already have this. So f is yz x squared xz. Okay, for this one here, I want to left as an assignment that you need to submit to me. Okay, since today is Friday, so you can submit by Monday. That one, I will give short notes in the Putra Blast that allow you to do submission in the Putra Blast. Okay, so just for this part here. So submit on Monday. Yeah. Okay, so I think that's all for this video, because next I think take a little bit longer time, so I think I better stop here, then we continue in the next video. So basically, just to recap what we learned today is just how to evaluate the line integral where C is the piecewise smooth curve. Yeah, so with that I thank you. See you in the next lecture. Bye.